Okay, so come back to our classes today. Yeah. So we have to go to this thing first. So this is what we go to days ago, and then we have talking about what is fatty acid, what is meant by triglyceride, and what is the fat and oils, what is different between the fats and oil, the physical properties, what is a solid, what is a liquid at room temperatures, and then what is the possible reaction that you will have on the triglyceride, which is something so-called hydrolysis, and also we have a saponification, and then we have a hydrogenation of a triglyceride, which I mentioned about shortening, and then we have also something talking about the waxes and what is the waxes do on the apply as a medical engineering, because some of the medical implant or something drug release, you need to have a waxes because the waxes is not soluble in water, and then so you can make sure the drug also make sure the ointment can be stay there a long time. So this is something that important of using waxes. And then also when the time we're talking about phosphoglyceride. Okay, phosphoglyceride is something very important major component of a cell membrane. And we have a two functional group of fatty acid there. And then with one of the things was replaced with the phosphate group, and also amino alcohol is something so-called phosphoglyceride. So when the time you have this structure, so we have a two tail there. This is two long tail, which is hydrophobic, and then you have another tail which is hydrophilic. So it will actually have a repulsion, and that repulsion will cause them to rearrange themselves in this kind of so-called 3D structures. So that's the thing. You will have a so-called hydrophilic head like this, and then you have a hydrophobic tails. Okay, but it depends on the unsaturated or saturated of the structure of the hydrophobic tail, and then you will have a cis trans also. Then it will give you different conformation of the phospholipids here. Okay. Anyway, when the time this kind of so-called phosphoglyceride, they will arrange themselves in this kind of structure, so-called bilayer. Okay, so definitely if I ask you, I will never ask you to sketch in 3D, but in 2D, it's very common that you need to draw something like this. Give me a second, I'm getting a picture that to illustrate what it's supposed to be. So actually, at least you have to give me something like this. Something like this. Okay, this will be better describe what it should be. Okay, so you have a hydrophilic head and also have a hydrophobic tail. So inside the body, inside your human body, we have major water content. So there's something so-called aqueous medium. So yeah, definitely they will let all that kind of a so-called hydrophilic part heading to the water, no matter it is in or outside of the membrane. Whatever we mentioned here is a cell membrane. Okay, in a cell membrane. Okay, I'm not sure if you guys still remember this stuff. Okay, a second. So we have this kind of so-called function of a lipid bilayer. So may I know, anyone can tell me what is this, the purple color stuff? Anyone? What is this? Gate. Carrier protein. Yes. Yeah, channel. Yes. Yes. Okay, this is very important to determine the function of membrane, because as a cell membrane, even not only about the membrane that we mentioned in cell, we have also membrane technology to filter the water, as I mentioned about the hemodialysis. Okay, is one kind of a function of a membrane. We try to mimic the function of a membrane by using the way so-called diffusion. Okay, then the one that you mentioned here, the channels, the carrier protein, so which allow a transport between two regions. One is a region A, region B. There you have a transport of neutron, oxygen, maybe, or maybe certain something like sodium ion, potassium ion, in order to make sure your body function normally. So this kind of so-called function of a bilayer is the key thing that to determine whether you are in the correct physiological system or not. So we have, give me a second, I rearrange the I mean, so the cell membrane lock the passage. So it will allow the molecule and ion in and out from a cell by two modes. So what is the modes that we mentioned here? What is the kind of two mechanism that we have for the transport? We name it, actually, this is so-called a transport. Transport process actually is a core subject in chemical engineering. Yes, Maisara, you are correct. One is a passive. So what is meant by passive? What is meant by active? So what is the difference between these two? Passive, active. What is meant by passive transport? Anyone? We start from passive. Okay, active need activation energy. Passive no need. Yeah, you can say activation. In the body, you need energy. No ATP is used that, so that will be very close to your biochemistry. So you will use ATP or not use any ATP for the transport. So you will have a so-called diffusion if you mention that. Okay, so passive. So if active need activation energy or ATP, so which is mean that passive no need. So what makes how passive transport happen? A movement of ion from higher concentration to lower concentration site. Yeah, diffusion. So it's very common. Yeah, osmosis. Yes, osmosis. Yeah. So it's very basic understanding about the transport process from the high concentration site to the lower concentration site. So you have a gradient. So all these kind of a thing. So we have a different concentrations, and then we have something gradients. Then we have also energy. No energy is needed. So it's very basic to understand what is meant by passive transport. And for the active, definitely you need energy. Okay. When the time you need energy, so that is a negative gradient. If it is in positive gradient, so you don't need energy. So it seems that you want to climb from the lower concentration side to the higher concentration area. So that's the thing, you need energy in order to support the motion, the mechanism. Okay. So actually, I supposingly to me a second. Actually, if we in the class, I will show you this lah.
Is how molecules move from a high to low concentration.
Okay, but here it is just waste of time if I ask you to watch this thing here. I will share the link in the in our e-learning, so hope you can take some time to go through this video. I'm not sure if our test will come from this video. Okay, please spend 11 minutes of your life watch this video. Okay, by copying notes from your friend, you may lose something. Even in the test, maybe your friend copied wrongly. So better just watch again this video by yourself, understand what it is. The way I do my class is I make sure everyone go through the assignment and also assessment individually. At least you understand what it is. If not, I'm not sure how you're going to answer my test question or also final exam questions. So the method that I'm applying now to another way to force you for the reading. Okay, so please watch this video. It's just telling you the important. Let me go to It is already summarized that you need for the passive transport, you will have a movement of molecule from the higher to lower concentrations. So that is something like you follow the gradient. Okay, then you do need energy. We have example diffusion, osmosis, and then we have also something so-called facilitated diffusion. And then for the active transport, you will have something movement of a molecule or particle. If you don't want to be specific, make it as a particle because molecule you do not have a charges. By the time you have ion, something like sodium, potassium, so that is not a molecule, name it as a particle. So movement of particle from a lower to higher concentration site. So actually you are against the gradient. So when the time you against the gradient, as I mentioned just now, you need energy. So this energy in your body is defined as ATP. Or otherwise, for the normal things that happen in your life, even how you're going to blow out a balloon, how you're going to induce that is a pressure difference. For example, if you blow air inside a balloon, now the air inside the balloon is higher pressure compared to our atmospheric pressure. How are you going to make sure the air keep pumping in? So you need to apply your lung pressure in order to force it in. So that energy applied by your lung is the external energy that causes the air molecule flow from the lower concentration side to higher concentration side, or otherwise so-called low pressure to high pressure. As what you learn from Dr. Nohana regarding the oxygen transport inside your human body by hemoglobin or myoglobin, that is also we have to know that the concentration of oxygen is very related to the pressure in gas. I mean, what we understand is so-called gas physical properties. High concentration means higher pressure. Okay, so this is how we're going to link up active transport inside your body. So here it is very easily to inform you that how you're going to transport something, nutrient, oxygens, okay, to your body. Okay, you see that we have our oxygen transport from here to your body. Okay, and then we have this thing. Please go through this. Okay, this video is quite simple. If you go to some other video, I think it's to biology. What we need to understand is just only this. In order for you to have an idea, if we need to have a so-called separation membrane for a filter, for a biosensor, in order to divide or separate certain nutrients from your body for a next stage justification or quantifications. Okay. So for the next, so phosphoglyceride, there is a lot of things related to membrane. And for the next, we will have this sphingolipids. Okay. Phospholipids are complex lipids. It is a complex lipids that contain so you have a sphingosine instead of gracilo. So actually your structures will be something like this. Okay. I only mentioned the key information that we need to understand from the sphingolipid. So actually, in certain of a biosensor, you have a sphingomyelins. Okay. Okay. Please make sure that you got this thing. Give me a second. So it is a structure that you have a choline attached to a sphingosine through the phosphate group. And how it is going to attach? It is along with a single fatty acid attached to the so you have actually amide linkage there. Amide linkage actually is not biodegradable in certain conditions because it is not hydrolyzable. So it's kind of very stable in terms of physiological system. Okay. But the key thing is where can you find this thing? It can be found in brain and nerve tissue. Okay. So actually, it will give you the structures of a nerve system, and then it will protect nerves. Okay. You will have something like this. And for the next, we'll have to learn about steroid. What is steroid? So what is steroid? As what we define steroid actually is just like this. See, steroid rings system. Actually, steroid is one of the lipids. Why? Anyone? Why we define steroid as a lipid? Yes, it's bulking out the muscle. Yes, it's an energy storage systems, and then it will induce your body physiological system. Your hormone will be different. That will be something. Even I have one of my friend. He was diagnosed to have a fourth stage cancer. It's final stage already, and then he need to take some steroid in order to make sure the body situation go to at least normal before end of his life. He need to consume some steroid in the moment. Okay, for steroid, why steroid is classified as lipids? Yeah, Yeah, steroids are lipids because they are hydrophobic and insoluble in water. Okay. Yes, it's very good. Yeah, because you already copied down every definition. It's very nice. As what we define lipids, lipid as long as you are a macromolecule which is not soluble in water, and then you are heavily contain hydrophobic structures, then you are lipids. Okay, this is what we learned from our first slide. Okay. So here, so steroid classified lipid. Okay, they are soluble in non-polar solvent. So that's the thing, you classify it as lipids. They are also not saponifiable because, okay, as I mentioned, we have a saponification issue here. Steroid cannot be saponified. Saponified. Why? Why it is not a saponifiable molecule? We have no ester. Ester is very important for the saponifications. So yeah, this is only every key things that you need to know. Okay. Also, as what I mentioned just now, that perform various functions such as hormone and contribute to the structures of cell membrane too. Okay, it's one of the way that contribute to the structures too. Okay, I believe that when the time you heard about steroid, you got this thing. But actually, for those who are in the final stage of their cancer disease, they also need to take some steroid in order to make sure their body situation function normally. At least physiologically, they don't have any issue for moving the body as normal. This is what I understand now, because my friend is taking some steroid, and then he's so good. He let me know every day about his feeling when the time he takes some cancer drug and also steroid, so I can have a record scientifically what is the effect of taking this. My friend just suffered lung cancer, and then the cancer cell already grow around the lung and also grow around the nose. So actually he got the diagnosis firstly done on the nose first, only then we perform the diagnosis of the cancer cell in the lung. Normally lung cancer was detected definitely will be in the last stage, because lung actually is something inside the human body, and then when the time you have a lung cancer, you will never see any different based on your physiological system. He feel unwell when the time he cannot talk. So when the time he got some issue on the nose and also on around the throat, yeah, that's it will be. For the okay, for next thing that we want to go through, I believe that some of you guys take this thing as your assignment. So it's kind of very basic for this. Okay. We have something related to cholesterol measurement in final exam. Please make sure you guys pay attention for those who will present in the coming days about cholesterol. Whatever you don't understand, please ask those to present. Okay. might be asked in your final exam. Okay, cholesterol is the most abundant steroid in the body. As I mentioned, cholesterol is the body. It is something energy storage or somehow. So it is an essential component of a cell molecule of cell membrane. Okay, and it is a precursor. It's a key stuff for other steroid. Precursor is mean that you are actually a reactant or a component that you have to build for another type of the steroid. Okay, so you need cholesterol to form, to synthesize steroid. So like the one that answered me in the chat box there. So hormones, vitamin D, and the adrenocorticoid hormone. Okay. So we have a steroid in this kind of structures, and this is very common steroid. Of course, then you have LDL, okay, lipoprotein measurement sensor. Most of the cholesterol sensor that measure only lipoprotein, lipids. Okay, so we will have that thing in our next lecture. But here, this will be understand the cholesterol result. So for most of the cholesterol sensor, then you will give you so concentration in how many milliliter of the blood containing how many milligram of the cholesterol. So it will give you this kind of idea. Actually, for the last year, we have this kind of questions. I show you something. I show you one of the past year question that we have. I don't think you can get any past year question from another for your senior. Give me a second. I'll show you something. Give me a second. I don't know why I cannot open my file. We have this kind of past year question last time. We are asking about lipid metabolism, but luckily we are not going to biology this year. We go to biosensor. So this is what we have. For me, it's not biomedical engineering. If we ask this thing, where is it? Give me a second. I can try to find some question for you to know what we asked years back. Yeah, this is one of the. Wait a second, it's kind of really late. Okay, we have this question is very related to your biomedical engineering. So normally we will ask this, for example, we give you a standard curve for the glucose measurement. So in the case that you have this kind of so-called glucose concentration, what will be the absorbance on the testing platform? It is either from the testing kit or otherwise from the UV spectroscopy analysis. So different concentration of glucose. So we will react it with different kind of enzyme, and then it will give you different color of the solution. So for different color intensity of a solution, you will have different absorbance. Okay, so this is how we're going to relate the standard curve for glucose. I'm not sure for your batch, is it I lead you guys for the lab 2? For 2 different years, one I asked students perform standard curve using microplate reader. Another batch student, I asked them to perform bio-based adhesive. For the batch that I asked them to perform microplate reader, they will have to creating a standard curve. And then for this case, we will ask the student actually perform the standard curve, and then we'll give around the absorbance value, so which is 0.5. So from that 0.5, you draw one line, so you will get actually the glucose concentration is around this region, 30. Okay, around 30 maybe, or 30 something. Yeah. So it will give you one idea of what is meant by hyperglycemia or otherwise hypoglycemia. So actually, we will ask the student what is meant by hypoglycemia and also hyperglycemia. This is also will give you the weakness of glucose meter, because glucose meter is somehow too sensitive, so it will give you a different level of the blood, the biomolecule in your blood wrongly. So it will give you wrong result. For maybe cholesterol, yeah, we will ask something like this. Okay. I'm not sure why we give only 5 marks for this question. This time we perform the final exam preparation for those who study in space. Okay, I think we will have to end our class today. I will need to go through this stuff. Biosensor to detect LD lipoprotein. Okay, so we have a lower density lipoprotein, which is a major carrier of cholesterol in your body, and which is also play very important roles in the cellular function and regulation of a metabolic pathway. For this section, which will be maybe next week or somehow, let's see when is it, I will discuss a lot about how to build a LD lipoprotein later, the low density lipoprotein, how to build this biosensor, what is the important component in the biosensor, how this biosensor function. I believe also those who present this topic will present the same thing. Okay. If there's nothing, then let's end our class today. Please make sure you guys participate for the group presentation coming days. Every of you need to evaluate. I hope there's no internet issue. You guys need to, okay, for example, if group 1 present, all of this remaining audience from another group need to evaluate. And for the evaluation, you just need to tick 1 to 5. I will give you some of the marks, and then you just need to tick it off, rename the file to your personal name, and then submit the form in e-learning immediately after the end of the presentation. I need to make sure everyone evaluate. I will not give you any marks from the presentation. I will calculate the average mark from there. So you have something like 5 to 10 for the presentation. So your friend will give you this mark. Okay, if there's nothing, then let's end our class today.